Good afternoon, everybody. Thanks very much for coming. I'm Harish Nadaraj, product manager working on unified infrastructure monitoring products as part of the AppDynamics family. And today we're going to look at how we can isolate underlying server and network infrastructure doing performance troubleshooting using AppDynamics APM. There's a couple of products that I'm going to be presenting today. One is a server monitoring product, which is in beta today. And there's also a network monitoring product that we're working on, and which is in alpha stage. So since we're talking about products not in GA, I have a mandatory safe harbor statement that is pretty much roadmap stuff that I'm talking about with respect to the network monitoring product. So I want to kind of like do a couple of things. I want to show you what's available as part of our server monitoring product and dive into a couple of real-world troubleshooting scenarios and do the same thing with give you a tour of the network monitoring product and do some real-world troubleshooting scenarios. And then we can go into Q&A. But if people have questions anywhere in the middle, feel free to just raise your hands. And sorry, was there something there? Feel free to ask questions anytime you want. So for demoing the server monitoring product, what we've done is we built this simple e-commerce multi-tier app. And you guys are very familiar with AppDynamics. So this is the equivalent application flow map view of, it didn't switch for some reason. All right, much better. It's the PowerPoint that's causing my problem. So this is the standard application flow map view. What we've done is, if you click on any one of these, you used to have the node view of the underlying tier. We've added a new tab which shows you the underlying servers that comprise this tier. And you get an instant view of the health, the key performance indicators of a server, CPU, memory, disk, and I/O, right there, and the number of servers comprising the tier. And we'll also allow you to drill down into a specific server and get a server-specific dashboard, and which gives you all the interesting details, including the KPIs that I talked about earlier. And a lot of customers are getting excited about this bottom part where they didn't have visibility into the CPUs, the processes that comprise on the server. And now we have visibility on what the top 10 processes are and what the top 10 processes consuming memory and CPU are. We'll also provide you this additional full process detail view where you know that it's not only the top 10, but what all the other available processes on the server are. Including that, you have the detailed view of networks and volumes, disk usage and volumes on the specific server. So you pretty much have Nagios type of views built in to the AppDynamics network server monitoring product integrated with the application flow views. In addition to just the server monitoring metrics, we've added a new capability called service availability. And what service availability does is like pingdom for the internal data center. So you might have periods of very low load, for example, during maintenance or right after maintenance, and you want to put some synthetic load from within the data center. And you can use this thing to drive synthetic load. And another use case for this is when you have dependencies that are not part of the AppDynamics flow map, you can service check these things. And what I mean by service checking is just a URL health check, and when you get a response, you can actually look at a regex and say, is the response at 200 okay? Does the body have a specific parameter that I'm looking for? And if not, fail this check type of thing. So that's kind of like the brief tour. And what I want to do is actually talk about a scenario where we can actually, at a real world problem, so in this application, what I've done is I've set up service availability checking for the inventory tier. and coming off from a central place in the data center. And that's pinging this service on a regular interval and reporting status back. And the scenario, I'm going to inject an intermittent fault between the e-commerce server and the inventory server. So the symptoms are usually going to show up in the application where the application is going to show a lot of errors. And since it's intermittent, you're going to have a lot of choppy errors and choppy response times. And we'll see that shortly here. If I go into the application, if I drill into the e-commerce server, you can see that this is the errors that the e-commerce server is exhibiting when talking to the inventory server. And on the right-hand side bottom of the screen, you see a lot of errors, and it's extremely choppy. And those errors, whenever the errors peak, you can see the load is actually having a trough. So every time a connection problem happens, the client load falls, and the response time goes awkward. And one of the questions that comes into mind is, like, why is this problem happening? And how can I diagnose it, whether it's an e-commerce server problem, or is it an inventory server problem, or somewhere along the path? So what I'm going to do, since I set up service availability checking on the inventory server, I can switch to my service availability checking view. And I see here that all my checks have a 100% success rate, and the response time is a really smooth 2.5 milliseconds. So now I know that from a different point in the data center, getting to the inventory server is working just fine. It's only when the e-commerce server is talking to the inventory server is this type of symptoms happening. So this kind of gives me a clue that the problem is not with the inventory server. It's somewhere along the path between the e-commerce server and the inventory server. So now you can sort of like eliminate, you had 3 points in the troubleshooting equation, and you've eliminated 1 point, and then you can focus on the path. And when we get into network monitoring, I actually talk about how you can actually figure out what the path is really doing. Is the path really the fault, or is the e-commerce server the problem? So that's one scenario. Any questions here? This is going to be available as part of 4.2 general availability, and that's tentatively scheduled for end of January of next year. So, yes, absolutely, yeah. We'll follow up with right after this. We'll get into the network scenarios as well. So the second scenario, again, a real-life scenario, is when the e-commerce server is talking to the order processing server, and oftentimes people run, antivirus scanners or IPS or intrusion protection software on servers, and some of these, sometimes the configuration gets messed up that they start consuming too much memory or too much CPU. And if that happens, your application that's sharing those resources on that specific server is going to get impacted. And in the AppDynamics APM product, what usually happens is when that slowness happens on a server, transactions going from the e-commerce server to the order processing server will be snapshotted. And when snapshots happen, we've added a new capability to show you what the server-side resources are so you can figure out contention issues. I'll show you how we can actually drill down into that. So since I think my problem's in the inventory server and the CPU is spiking, I go in and I look at transaction snapshots for the inventory server. And let's say I pick one of these. And this is an imaginary scenario where a antivirus or a IDP is like consuming too much CPU. We now have added a new tab in the snapshots which provide you full server level metrics, including all processes that are consuming resources on that server. So if the CPU had spiked for several minutes, and that's what's causing a snapshot, you could drill down here and see which are the top processes consuming CPU. And of course, your antivirus, if it's pegging the CPU, is going to show up on this one. So you have a clear indication of what's consuming, sharing resources on the system, and causing contention problems. So it's an easy way to see what's going on the server. Any questions here? That is correct. So in the snapshots, when a snapshot happens, we're taking all the server data 15 minutes and 15 minutes before and 15 minutes after for the specific snapshot. So you have a trend line of what's happening. And then you can see whether the CPU is spiking 15 minutes before or it only happened like 2 minutes before. So you have an idea of what's, how the different processes are behaving in that system during the time of the snapshot. Yes, so that's something that we're adding. We'll add baselines for all metrics, so you would have an idea of how those processes are behaving compared to baseline. Yes, 4.2, the server monitoring is GA, and it's part of the machine agent. If everyone here is familiar with, I hope they're familiar with the machine agent. That is our delivery mechanism. Our machine agent has two types of functionality. One is it provides basic hardware metrics, which you get today as part of the 4.1 release. In 4.2, we'll continue to provide the same basic metrics. But if you buy a special license, that machine agent will magically give you all these extra features. So if there's no more questions on the server part, I want to get into the network scenarios and our networking. Yes, please. Backwards compatibility with the controller, or? Yeah, the question was, what is the backwards compatibility? Do you have to upgrade the 4.1 machine agents to get this additional functionality? And the answer is yes. The machine agent has been enhanced to provide these additional metrics and additional functionality. So you'd have to upgrade those machine agents to 4.2, and also upgrade your controller to 4.2. That is correct. So the basic machine agent, the machine agent is just a delivery mechanism. There's two forms of features. The basic features that come with the APM. When you purchase an APM agent, you get a machine agent along with it. That provides basic hardware metrics that you get as part of 4.1. But if you buy this additional license, you get all these extra features. So in terms of network, I want to just talk a little bit about our technology, which is, yes, please. Great question. So what we do is it's a lease type of mechanism. So if you buy like 10 licenses, and you can specify on the agent which agent wants, where you can configure additional SIM features or not. So on a per agent basis, you can say, I want server monitoring enabled on this. And so you could have machine agents that don't have server monitoring and certain machine agents that have server monitoring, and they will consume the correct license. That is through the controller info.xml. So it's a small XML file, the configuration file for the agent. And when you use Puppet or something to push it there, you can configure it to say, yes, server monitoring is enabled on that. So. We have plans to actually enable it directly from the controller admin pane. But with the 4.2, it's sort of like we're taking baby steps there. So in terms of network, I want to briefly touch on our technology, which is unique and differentiated from other networking players, and it's highly integrated into our current APM product. Our machine agent is going to be extended to do lightweight packet captures. We are going to be running and capturing all TCP connections that are related to the application flows, and it's extremely lightweight captures. This is not a full payload capture. We only care about the TCP payload, which is 128 bytes of every packet. And so typically, when you have a machine node A talking to node B and exchanging messages, that message can flow through multiple TCP connections and also multiple devices. and could get natted multiple times. So the problem with conventional network monitoring devices is when you have a problem that you want to diagnose, you'd have to go into every single segment here that interconnects these boxes and take a full packet capture, and also take box-level metrics like load balancer, switch metrics, and then manually somebody has to understand how the application interacts, and somebody has to take the underlying network metrics, understand how the application works, and manually stitch all these things together. So you have some fantastic products out there on the network that do an amazing job of getting these metrics. The challenge is somebody on the network side and somebody on the application side have to kind of work very closely together, understand both these components, and then put these metrics together to figure out, yes, it is a network problem, or no, it's not a network problem. The way we're solving that is because we have tag and follow technology, and that's how we draw our application flow maps. We know that a message of business transaction went from node A to node B. And that transaction actually, in this case, went through a dark green TCP connection on the left-hand side and a light green TCP connection on the right-hand side. What we're doing is, since we're doing packet captures, lightweight packet captures on node A and node B using the machine agent, we extract source IP, source port, destination IP, and destination port information from TCP flows. And then we get the same source IP, source port, destination IP, destination port information from the business transaction. And that's how we can actually tie a specific business transaction directly to a specific TCP connection. And then we can also say that these two different TCP connections are actually related, and that's how our business transaction actually went through both of them. And if TCP got degraded, your business transaction is going to get degraded. So we track very closely all TCP metrics, and we can automatically correlate it with the business transaction. And that's our differentiated technology. Any questions here? That is correct. What I've shown here is a load balancer proxy. It could be Nginx, it could be F5, it could be NetScalers, it could be HA proxy, whatever. So. Yeah, so great question. What we track is end-to-end TCP connections. That TCP, the packets that comprise the TCP connections might go through the firewall and might get natted, might get dropped. But what we're sensing at the end server is we're just sensing a whole bunch of retransmissions. So we know TCP is degraded, and we know the quality of TCP, and we can relate it to the business transaction. And so it may be the firewall, it may be the load balancer, but we know the entire TCP is getting degraded. So. And yes, please. Are you talking about L2, L3 topology? So that's something we've talked about. And in fact, let me switch to that slide here. This is what we call deep path analysis, where we can actually inject synthetic traffic from a specific node to its destination node. And this is L3 TCP traceroute. And we can actually map all the hops. And this is on our roadmap. But some of the problems is in today's data centers, a lot of them are getting very SDN-centric, which is very, VXLAN and things like that. So even if you do this, you're not going to be able to see all the topologies. So that's why we want to operate at an abstraction at the TCP level, which is more important. And newer data centers have 128 paths going from the inventory tier to the memcache tier. So if mapping 128 paths, I mean, how useful is that going to be? I mean, it's going to be pretty... it's too much information to deal with. So the problem we're trying to solve here is not replace conventional networking tools. We want to enable the application operations people and the IT ops people to say definitively, yes, there is a network problem, and here is the data that conclusively proves there is a problem, and they can take the data, go to the network specialist and say, here, I have proof. Please use your riverbeds or whatever you have to figure out further where the problem might be. So we're not trying to completely replace all the networking products. What we've heard from customers is when a problem happens, the symptoms usually show up at the application layer, and application teams spend an enormous amount of time trying to troubleshoot something that doesn't belong to them in the first place. And even if they realize that maybe it is a network, they don't have the right data to actually escalate it to the network people. They call the network people and says, oh, I look at my tools, everything looks fine. And then when we talk to network people, we hear the opposite, where they say, well, oftentimes I get blamed unfairly. So what we're trying to do here is to reduce all that back and forth with actionable data to prove there is a problem or not.
Will this require an extra license as well?
That is correct. Yeah.
So the server and network are two separate licenses?
That is right. That's how it is right now. They may be, can't speak to the future, but there may be a possibility of bundling there. So.
If you're running multiple JVMs on the same machine, do you have to have the networking machine server module running on each JVM on the same physical box?
So are the JVMs running directly on the bare metal, or are they each one in their separate VMs?
Same bare metal.
So you just need one machine agent for one single bare metal, or one VM. So it's on the host basis. So. So I want to actually give you a quick tour of that product. So this is another e-commerce application which is multi-tier, and you're all too familiar with the application flow maps. What we have added is the capability to click on one of these links, and this new thing shows up called network. And if you look at that, it gives you key metrics, throughput, latency, and loss, in correlation with response time. There's probably some glitch on that link there. It's still in the alpha stage, so bear with me. But here you have all the information here. TCP loss, latency, and throughput in correlation with the response time. And then we've also added this new network dashboard, which provides a underlay view of the exact application. So this is the same application that's been rendered from a network perspective, which is the L4 TCP view of it, including your load balancers that have been automatically discovered. So on any of these links, we have 3 metrics, and they are latency and loss and throughput. The reason that we pick latency, loss, and throughput is they are KPIs from a network perspective. If latency goes up, your application's ART is going to go up. If loss increases, your application's ART is going to increase. And throughput is a good indicator of how much your network is being used. We also have flow groups. So when communicating between network teams and application teams, people don't speak the same language as network people, and network people talk in terms of ports and VLANs and IP addresses. So we make it very easy here to show, okay, for the communication going from the e-commerce tier to the load balancer, these are the IP addresses and ports in use. And we'll also allow you, if you give us read-only access to your load balancers, if you click on one of these, to provide a visualization like this, which is a full, from a specific virtual IP, its internal configuration for that VIP, including its pool members, the I rules, and all the right statistics in one place. So it makes quick troubleshooting scenarios very easy. So you have the load balancer guy, you have the network guy, and you have the application guy looking at the same view here, and there's data showing that whether it's an application problem or a network problem. And then we've also, you can drill down into a specific node level here. And then what we're doing is we're taking, all this used to be manual, layer 1 to layer 7 of the server health. People used to do a bunch of netstat, ifconfig, and maybe look at the TCP proc system to get a bunch of metrics. We are automating all of that and color coding it using baselining and thresholds. So you'll have health from layer 1 interface to all the way from DNS and SSL. From an SSL perspective, we will do baseline SSL handshake time. We will look for SSL certificate expiry and warn you about that. From a DNS perspective, we will track query and response time and black holing. So if you get DNS black holes, we'll notify you about that. If your DNS query times become very high, we can correlate it with the application response time. Similarly, with IP, we can track fragments, MTU mismatch issues. everyday networking problems. We'll cover all those things from a server perspective. Any questions here? Slides or the application?
The application, the flow map that you were showing.
Okay. Yeah.
Yeah, I mean, that's fine. And then you were showing on one of those connections, I think you clicked on it, and then you showed the network, the new network tab.
Yep.
And then that showed you like latency and all that kind of stuff.
That's right.
We do a lot of data center moves. And so lots of times the elements of the application are going to be separated during that move. You know, before or after the move. So what would be great to be able to do is go into that latency. And if I were to separate that connection, say I have to add 10 milliseconds, it tells me what the impact is.
So if I understand you right, which connection are we separating?
Any one that we choose.
So you want to be able to say before and after the move, you want to compare? So are you doing like A/B testing scenario where you have two nodes on one data center and two nodes on a different data center, and then you want to compare them?
Our baseline is the current environment, and then we use analytical modeling tools for the proposed environment.
Okay.
It would be really nice for this to come in, and that's our current environment, and then just simply go in there, change that latency number, give it the what if, say, if I were to separate this connection, what's the impact?
So you want analytics from us? Okay, that makes total sense. Yes. Yes, sir.
So as long as we're talking about wish list, when you're looking at some of the analytics, most of them are based upon averages, but what I care about is variation from my normal. So if we start looking at things like when you break out of the standard deviation, that would be an interesting event to have. If you do any measures of skewness of how the data is coming out, like a kurtosis or something like that, that would be interesting. On that. The other point, and I'll be brief, is that when we look at the averages, they're really interesting in that window. But if I look at my daily flow of traffic, I might have peaks at, like an email system has peaks in the morning, lunchtime, and end of day, or something like that. So
Yeah.
those have business processes that have peaks, and it would be interesting to understand if you've broken out of a range during that particular part of the day or day of week.
Yeah, so our product has this concept of baseline and standard deviation-based alerting. So the same thing that works on the application side, everything will translate directly to the network side. And all the alerting from the network side will be connected with the application ART. So you get one alert instead of getting one alert from the network side and one alert from the application side. Ultimately, it's all about ART, right? So we want to show causality. So if ART alert fires and if network is also, the latency or the loss is increasing at the same time, then we'll coalesce that into one single alert and give you a health rule alert that indicates that thing. And the same seasonality-based baselines, everything is going to be applicable here as well. And in terms of, we'll actually get into a scenario because networks have things known as microbursts, and you might have sudden heavy load. And traditional SNMP tooling, polling at 1 minute interval and 5 minute intervals will not pick up on those things. We have unique technology where we can actually tell you that certain transactions, snapshots, are happening because of microbursts. And I'll show that in a scenario in a minute. So.
Is the information available in the metric browser?
Yes, all the metrics that are on the system are still accessible from the metric browser. So. So right now we're in alpha and we're looking for beta customers. So if you're interested, right after this, we could, if you come here, I can take your information and then, we can get some things started. But once we get into beta, the current projection is the second half of 2016 is when we'll probably have a GA. So. Yes, sir. So right now it's only Linux and Java, and once we have GA for Linux and Java, we'll add .NET and the dynamic languages and Windows and other Solaris and AX and things like that. So. Is there a question there? This is not going to be part of the 4.2 GA.
Right, that's what I was wondering. So I know you have the licensing on the agent on the actual node, controller end. It sounds like these features you're talking about now are different licensing upgrades, correct?
That is correct. So the first product I showed you, server monitoring, that's going to be GA, and that you can buy with a new license. But what I'm showing you now is not going to be GA as part of 4.2. But if you're interested in beta, yes, we can enable that on a 4.2 controller. Yes, sir. Great. Yes, that is on the roadmap. One of the key pain points that I've heard from customers is when a network person asks an application person for a capture, this is a huge language and technology skill barrier where they have to say these squiggly Wireshark filter parameters, and app people are like, I don't know what the heck that is. So we're going to make it really easy to say, right-click on this and capture traffic for these set of business transactions for 2 minutes or 3 minutes, and then directly move it to the controller, and from the controller get it onto your desktop. So it's going to be very easy, and one-click email sharing with a network person. So the troubleshooting process becomes much easier. So. You can configure, by default, we'll allow picking specific BTs. But you can also say, I don't care, just give me all traffic on this box for the next 5 minutes or next 10 minutes or whatever it is. So. Yes? So we're working off the end server nodes, and the only thing that we will sample is if you give us access to the load balancer. We do have plans in the future to add layer 2 and layer 3 devices, but right now our target is our existing application and IT ops people, and the struggle that they're having is, I don't know if this is a network problem, or if it's a network problem, where is my data to actually escalate to the right person? I've heard customers say, I go on 5 different calls when a problem symptom happens. I call the network guy, I call the storage guy, and he looks at his dashboard, and the storage guy looks at the dashboard, the database guy looks at the dashboard, and it's a painful thing. So we have data now to say, yes, we see there's a network problem, the symptoms are showing up in our application, and so take this data, go look at your tooling, and figure it out. So, yes? So we can use our machine agent and directly use HTTP REST calls, SSH or SNMP, to pull the configuration and the right metrics. And one additional thing that customers have asked us is oftentimes problems happen after a load balancer change. So we can track load balancer WIP changes and alert people saying when was the last change made. And if the change was made in the last 5 minutes and you have a performance problem, then you have an indication on right there that the change was there. So. No, so the agent runs on any server. You could use any one of these servers to actually periodically poll the load balancer. Yes, we can do that. So I'm going to talk about a real-life scenario. And this is congestion. And somebody talked about peak loads and somebody starting a backup during peak loads. Or there are certain characteristics like TCP incast, TCP outcast, microbursts. And they happen because of many issues, maybe oversubscription, failing hardware, or just things like somebody did that massive backup job when primetime traffic was coming through. And this is a slide from a well-respected vendor in networking, Arista Networks. And what they've done is a whole bunch of studies that show that at any given time, a switch port doesn't treat all TCP flows equally. You have some flows that take enormous amount of bandwidth, some flows that don't get any bandwidth, and a vast majority of the flows somewhere in the middle that get the same amount of bandwidth. So if your client is doing a $1 million transaction, and if that transaction happens to be on the bottom left here, where it's not getting any bandwidth, then that's going to show up as a snapshot in our system. And you might have asked the question earlier saying, I'm getting these snapshots, but I don't see anything wrong with the application. I don't know who to blame. Is it the network to blame? And now we can provide the answer. And we can provide the answer by, if you go into transaction snapshots, right here, we've added a new icon that indicates that this snapshot was very likely caused because of a network problem. And, oh, sorry. So these are transaction snapshots, and we've added this network icon that indicates that these snapshots are very likely caused because of network congestion or other issues. So if I drill into one of these, and if I look at this, it looks like get pooled connection from data source, that is the database call, had a whole bunch of TCP loss. And TCP has a timer. Every time there's loss, the timer will time out and it'll retransmit. And every time a retransmission happens, the slower the transaction gets. And so when you have congestion issues, you're going to have loss, and that's going to cause your TCP transaction to become really slow. And that's why we picked up here saying that, whoa, that transaction was extremely slow. We also had another transaction in the database that had significant loss. So now, if this happens very frequently, you can take, there's a lot of technical geeky stuff here, which application people don't care about, but all they can do, what they can do is they can go here, and take all this flow data, which is all the gory details of why a transaction, a TCP level problem happened, and send it off to a network guy and say, this is periodically happening. It's happening like 3 times an hour or 4 times an hour. Can you use your tooling to figure out why it's happening? So when I ask customers, okay, how do you guys deal with a problem like this? Because this is a real world problem, and SNMP tooling doesn't capture it. And even if you had sophisticated tooling to figure out where microbursts are happening, taking that network level data and correlating it to the application is a huge challenge. So my question to you guys is like, I mean, is this something that you guys see, or if it happens, how do you think that in your current environments you would debug it? So, yeah, so that's why we have, when this thing happens, we can actually capture the specific flow. This is one single snapshot, and so we have definitive proof that this TCP flow and this snapshot, a business transaction, was affected because of microbursts. No, we could automatically do the capture as well. We're not doing it right now, but what we do is when a snapshot happens, we automatically capture the rest of the flow. So, yes, please. Yes, I mean, you can say that automatically capture and capture for so many minutes, or capture all these extra set of flows. Yes, it will be totally configurable. That's the idea. Yeah, so we don't have to run on top of the database. So if I go back to this dashboard here, I don't have any instrumentation in this database. I have only instrumentation on this tier. And we're looking at transactions going into the database from this end. And if you did have instrumentation on the database, it's going to be extra information, but not necessary. So that is correct. We're doing lightweight packet capture on every server. That's right, yeah. The tier that's talking to the database, that's where we're doing the captures. Yeah. Yes?
This solution that you showed, both in terms of server and network, do they work in other environments other than e-commerce as well?
So you're talking about high-frequency trading type of thing, or?
Other infrastructure that wouldn't be necessarily providing infrastructure to e-commerce, other applications.
Oh, so for the purpose of the demo, that I just said e-commerce, but wherever AppDynamics works, I mean, AppDynamics works in so many different verticals, banking, finance. So, it's going to work in every single AppDynamics vertical, yes. So the next scenario I want to talk about is pinpointing loss. For loss, what we're going to do is if we inject loss between the order processing tier and the payment gateway tier, the symptoms are going to be that your average response time of the application is going to significantly go up. And this slide actually shows the effects of TCP loss. And these are real-world studies showing that even a small amount of TCP loss causes a significant amount of drop in throughput. So if transactions were experiencing loss, those transactions are becoming really, really slow. And they may not be snapshot because snapshots are outliers in our system. And if loss is consistent across all snapshots, the entire ART for that tier is going to become significantly higher. Prakash, are you here? Prakash? Are we? So for the sake of time, saving time, my friend here has created some dashboards. Is it 15 minutes or last 5? Oh, 1 hour. If my Wi-Fi connection works. Well, while that is loading, I want to give you a sample of what I'm about to show you. Like, this is a test that was done a little earlier during the injection. And what happens is we're tracking the average response time between the order processing tier and the payment gateway tier. And the average processing ART was in milliseconds and was somewhere around 20. And we injected random TCP loss. And we found that the ART really spiked. And if you look at the curve at the bottom is the amount of TCP loss that we're detecting by the packet captures. And you can see that the data loss curve exactly follows the ART. And the moment we cut loss, the ART comes back to normal. So on the left-hand side is ART in milliseconds, and I think the time is around 2:30 is what we're looking at. You can ignore the rest of it is because we were just fine-tuning the application. Oh, yes. Was that? 208, okay. Well, the 230 one, yeah. So you can ignore this part is when we really started starting up the application and we had some issues there, but right here, the ART really spiked and when we introduced loss here. So there's a direct correlation, and how our system is going to work is we're going to take a health rule alert based on baselines, which is the ART health rule alert, and we'll take the network level health rule alert and combine the two and send one single alert out saying that loss at this specific tier is what's causing the application ART to spike. Any questions here? So typically, how do application people diagnose loss level issues today? I mean, is it something like a call to anybody have comments on how things are done today? So if the network is actually causing loss and the symptoms are showing up in the application, what happens? I mean, how does an application, because the symptom is going to show up in the application, the call goes to the app ops person or the IT ops person who's dealing with the application, and how does she diagnose that this problem is actually related to a network level loss problem?
Yeah, I can give my thoughts. So
Sure.
from my organization, I'm in the apps world, and so when we have an issue come up, it usually manifests itself at the user. A user will call us, they won't say the network's down, they won't say the database is down, they'll say the application doesn't work. So that's our starting point, right?
Mm-hmm.
And then we go through a series of troubleshooting steps that might lead to some hazy or cloudy evidence that might suggest it's a database or a network issue. So we call, you mentioned this earlier, you know, you call those teams, and it can be contentious at times, you know. How do you know it's a network issue? How do you know it's a database issue? And one of the things that we're really hopeful for with AppDynamics is it kind of gives us that full picture. Now we also have the machine agents, and because this is going to require us to buy additional licenses, I think the ultimate question from where I sit is, does what I get from the machine agents we have right now suffice? Is that going to give us enough information to have those intelligent conversations with our infrastructure partners, or do we need something additional to that?
So when you say the current machine agent that's coming out at 4.2, right, with the server monitoring or with all these features in the future?
No, we have 4.1 right now, and
Okay.
we have machine agents.
Yep.
We get kind of that basic level stuff.
Yep.
And I think that's the question, is that going to help us enough? And if it is, then we don't need this. But if it doesn't, then we might need this, right?
That is correct. So what the current machine agent does is it gives you basic metrics like CPU, memory, disk, and network, I/O on each server level. But it's not going to, you know, for example, having microbursts, it's not going to be able to tell you that this transaction was affected because of microbursts. If you're having significant loss, it's not going to tell you that the link is having loss. It's going to basically say there's network I/O is going down, but it's not going to tell you that network I/Os are going down because of loss level issues, or why is network I/O going up.
But is that just network I/O measure enough to get our network partners to say, okay, we're going to use our tools now to dive into it deeper? Because like you said earlier, the intent here is not to replace you know, infrastructure-specific monitoring tools that our infrastructure partners already have. So it's just, you know, that's what we got to figure out, is at what point does it get us to the level where we can have that conversation later?
Yeah, so network I/O alone is not going to give you an idea of where the problem is, because network I/O could be going down because your load may be going down. But in this case, when you're troubleshooting something, your load is already down because of its loss. When there's loss, your load goes down, your throughput goes down. And then all that network I/O graph is going to say is like, network I/O is down. So they're going to ask you the question, I mean, how can you tell that a network is actually causing your problem? Because your load might be going down, right? So you need definitive proof that KPIs that indicate there is a network problem. And network I/O is not necessarily a KPI. Like ART is a KPI, and how ART is impacted because of loss, latency, and some other network problems. And that's what we want to try to surface. So. This is a data center product. We're not focused on the end user. We do have another product called the end user monitoring, and that kind of gives you the end user's picture, and it also ties the transaction all the way from the end user into the data center. So we have snapshot follow through all the way through. So. Mm-hmm.
Then we're not sure if it's the VPN through their internet provider because they're remote,
Mm-hmm.
or truly what part of the network is causing the problem.
Mm-hmm.
Right? So if we had the end user module,
Yep.
we understand what that user is going through.
Yep.
Then you've got the network.
Yep.
Then you can sort of look at the whole ecosystem and then decide, okay, no, it's not the network, no, it's actually code or something, right?
That's correct.
Process running on some of our logic servers. So that's where I would think you need all of that to know where it's outside.
That is right, but just given what AppDynamics initially started out was within just the data center, and looking at transactions within the data center and saying, you know, what's the cause of my slowness? Is it the application? Is it the source application? Is it the destination application that's causing the problem, or something in the middle, right? And so if you just focus on that, you have information. And then if you have the EUM, you have additional information how to tie it to the end customer. So. And some customers have said, even though I'm saying that this is not designed to replace Riverbed and things like that, those tools have a lot of bells and whistles, but some of our bigger valuable customers have said that I don't think I need all those fancy things. Most of my 70% of my use cases are already covered from what you're saying. So I'm actually seriously thinking that I could, if you provide the packet capture capability and the programmatic capability to apply the filters, I might be replacing things like Riverbed and things like that. So. Mm-hmm. Yeah, so that it goes back to this, the technology slide here, where SolarWinds is really good about. So SolarWinds is really good about getting fantastic metrics out of L3 switch, the load balancer, the firewall, the other L3 switch, and maybe even the server metrics. But somebody has to spend hours and have the expertise who understands the application and the network and these metrics to manually take all these things and make the bigger picture. And what we're doing is when you deploy us, instantly you get not only the application topology, you have the underlying topology, and it's automatically correlated. So you don't need a rocket scientist or a PhD in networks and metrics to take all these things and build that big picture for you. So. Do I have 2 minutes or? No. Any other questions? Or? Yes. It's going to come. Right now, we're focused on Java and Linux. A subsequent release will have Windows and .NET. So. Is there another question? Yes. Yes, so we do have this notion of TCP sockets. If I drill down into the node level stuff, so I think the problem that you're talking to is commonly known as port exhaustion. And we do have a special scenario for this, but because I had to compress 2 different products, I did not include that. But we do have detection of port exhaustion and tying it to a specific business transaction and a specific application flow, and saying that you're running out of sockets and all these sockets are in time wait state or fin wait state, and indicate how frequently they're going into that state. And conventional tooling is going to tell you that a specific server has too many sockets in fin wait or time wait. It's not going to tell you that specific application flows are related to that stuff. And somebody has to manually do that correlation. We're automating that stuff. So. Yes? We don't do anything special on the network layer. We're very passive. All the injection happens at our BCI layer at the application level. We do have plans for running off-box. So there might be scenarios like an IBM mainframe, or there may be scenarios where there are too many microservices and there are very small provisioning for those microservices, and you want to run on the host. So in that case, what we'll do is we'll suck packets from the host, and we can actually look at we can look at the we can do deep packet inspection in that case to figure out what we call as the singularity header, how we track those transactions between node A and node B. But there's something on the roadmap. Yeah, so going back to this, if you had the capability to work off taps, and not only end servers, you might say, I want to tap between the firewall and capture there and correlate automatically with the application. That's right. That's correct. And I think our conversation last night about appliances, we're not thinking about building an appliance. We're thinking of taking our agent and scaling it to 20G or 40G on Whitebox solutions, And what I mean by Whitebox is you buy a standard Intel server with the configuration we give you, or you provision it on AWS with the right configuration, and we'll scale to 20 gig of traffic using either a tap or a span port. In the case of Amazon, you'd have to have a special, what they call it, the bump on the wire to capture those packets. But you don't need any special appliance. We're just going to run off Whitebox, and the same agent that we're deploying on these servers can be deployed and scaled up vertically in those cases. So, yeah, that's right. Yes, sir. Sorry, I didn't hear that. Yes, I can. If you give me your email, I can send you the slides. I can take your email down at the end of this. And if you're interested, we could also do an in-depth session. We've done an in-depth session with some of our customers. This is a compressed session. We have like 6 different scenarios, which are very common everyday problems. And we can go into that in-depth in those cases. So. So Electronic Arts, when I was talking to them, they said, "Oh, we're in the gaming business. Can you do something on the mobile phone?" But the problem is, no one's going to allow us to run and get OS level stuff from these types of phones because they're highly secure and you have restricted access to any of the OS level stuff. Cisco iOS. I said, okay. Sorry. Cisco iOS is maybe something in the future because right now that the lowest hanging fruit from an application perspective is load balancers. But once we want to expand to L2 and L3 devices, then we can do SNMP polling and actually do L3 path mapping and things like that. So. But thanks, everyone. Really appreciate the time you've taken.